Hello everyone, welcome to Talk Mathematics. So this is the sixth video of doing chapter 1 sets of NCERT class 11 and today we will be doing exercise 1.5. So let us see some of the basics that are required for this exercise. This is complement of a set. So we consider a universal set first U, which is already discussed in previous video. You can go watch the previous videos. So this is a universal set U. Suppose it has elements 1, 2, 3, 4 and 5. So let us write it down here. U has 1, 2, 3, 4 and 5. Now we will construct a set. Suppose this red color set is A set. This one. So A set contains two elements, which is 3 and 4. Now complement of a set. Complement of a set is those points which are not present in A. So I am shading the region. The green color region is that one which is not present in A. This is A complement. So A complement is denoted by A dash or AC and it contains elements 1, 2 and 5. So you have to think only in this box, in the universal set only. So two more properties which can be understood from here is that A is also a subset of U and A complement is also a subset of U. Now let us see some of the properties of complement of a set. So first property is A union with A complement makes the whole universal set U. So we have seen that if this is whole universal set U, this one is A and A complement is this one. So you can clearly see if we together we take A and A complement, it becomes the whole universal set U. The second property is A intersection with A complement is phi, which is empty. So you can see from here, if we see anything common between this A set and A complement set, we cannot find anything. So this is empty. Next property is the De Morgan's law, which says that A union B whole complement is equal to A complement intersection B complement. Another property of this is A intersection B whole complement is equals to A complement union B complement. Another one is A complement whole complement is equal to A. So if we consider A and A complement and then A complement's complement, which will become A. Then sixth property is the complement of phi is equal to the universal set U. So phi is an empty set and whatever complement means whatever is not present in phi. So what is not present in phi? Everything is not present, so it will become universal set. Then one of the last property is U complement is equals to phi. U is the whole universal set and if we take its complement, so what it will be? It will be nothing is present, so it will be. So that's all for the basics. Now let us see example 20 for exercise 1.5, which says that universal set is this one and A is this set. What is A complement? So A, you have to think inside this universal set and whatever which is not present in A. So 2 is not present in A, then 4 is not present, 6, 8 and 10. So A complement becomes this, whatever which is not present in A but is present in the universal set. Example 21 says that U be the universal set of all the students. So if U is all students, okay, and A is the set of all the girls. So A is the set of all the girls. What is A complement? Whatever which is not present in A but is present in U. So this will be the set of all the boys of class 11th. Next, example 22 is very interesting example because in this example we will prove the property of De Morgan's law, which we have written in the properties section. So let us see, this is the U universal set which contains 1 to 6 numbers. A is 2, 3 and B is 3, 4 and 5. So firstly we have to calculate A complement. Whatever is not, which is not present in A but is present in U. So it will be 1, 4, 5 and 6. Then we have to write B complement. B complement is 1 and 2 and 6 also, which is not present in B but is there in U. Then we have to write A complement intersection B complement. So intersection means we have to find the common things. So common things in A complement and B complement you can see from here is 1 and 6. Then we have to write A union B. A union B means we have to write all the elements of A and also the elements of B. So A has elements 2, 3. Then we have to write elements of B. B has 3 but we have already written. Then we have 4 and 5. Okay. So let us begin with the left hand side, which says that A union B whole complement. So we know that this is A union B and we take its complement. So whatever which is not present in A union B, it is 1 and 6. And the right hand side says that A complement intersection B complement, which we have already written here, which is also A 1 and 6. So from this left hand side is equal to right hand side. So from this example we have proved the property of complements, which is De Morgan's law. Now we are done with all the basics and examples. Let us begin with the exercise 1.5 first question. So this is the first question, which says that this is the universal set U, this is A set and B set and C set. So first part says that we have to find A complement. So A complement will be whatever which is not present in A, so which will be 5, 6, 7, 8 and 9. Second part is B complement, whatever which is not present in B. So this is 1, 3, 5, 7 and 9. For third part, we have to take A union C complement. So let us write A union C first. So A union C is written as all the elements of A and all the elements of C. 3, 4 already written, 5 and 6. Now taking its complement, A union C complement, which is not present in A union C, is 7, 8 and 9. We have to think inside this U universal set only. Next, fourth part is A union B complement. So firstly we have to write A union B set, all the elements of A 1, 2, 3 and 4, and also the elements of B 2, 4 already written, 6 and 8. Now taking its complement, the things which are not present in A union B are 5 and 9. Fifth part is A complement's complement. So you know that A complement is this. Now we have to write A complement's complement, means all the things which are not present in A complement. So A complements will be 1, 2, 3 and 4. And from the property also one more property of complements is proved here, that A complement's complement is nothing but the set A itself. Sixth part says that B minus C complement. So first we have to write B minus C. That means from B we have to remove all the elements of C. So C contains 3, we have to remove 3 from here, but 3 is already not present. We have to remove 4 from here, we have to remove 5 but it is not present, and we have to remove 6. So B minus 6 is left with 2, 8. Now taking its complement, B minus C complement is everything which is not present in B minus C, 1, 3, 4, 5, 6, 7 and 9. Second question is, this is the U set. We have to find the complements of the following. So for first part, let us calculate A complement. Now the alphabets which are not present in A. So D, E, F, G and H is not present in A. For second part, B complement. Alphabets which are not present in B. A is not present, B, C, D, E, F and G is present, H is not present. Third one is C complement, which is B is not present here, D, F and H. Fourth part is D complement. A is present, B is not present, C, D, E, F, G and H are present. So this only. So let us see now the third question, which says that taking the set of natural numbers as the universal set. So what is U? The set of all natural numbers. So we have to write down the complements of these parts. So the complement of first part is X is an even natural number, so what is not present in X? It is the set X where X is an odd natural number, right? Second part is X is an odd natural number, so its complement will be X such that X is an even natural number. X is a positive multiple of 3, so it would be of those set which is where X is not a multiple of 3. That means X belongs to natural number minus something 3n type, where n is also natural number. It will contain all those numbers like it contain 1, 2, 3 it will not have, then 4, 5, 6 is not present here, then 7, 8, 9 is not present, 10 and so on. This set will go like this. Then fourth part is X is a prime number, so a number which is not prime is composite number, so X is composite. Next, fifth part is X is a natural number divisible by 3 and 5. So we have to construct a set of natural number not divisible by 3 and 5. So 1, 2, 3 will not be present here, 4, then 5 will not be present here because 5 is divisible by 5. Then 6 is also not present here. Then we have 7, 8, 9 will not be here because it is divisible by 3. 10 will also not be here, so 11, like this, so on. Next, sixth part is X is a perfect square. So we have to construct now a set where X is not a perfect square. So we know that 1 square is 1, 2 is not a perfect square, 2 is not the square for any number. Similarly, 3 is not the square. 4 will not be present here because yes, 4 is a perfect square of 2. Then 5, 6, 7, 8, 9 is a perfect square of 3, so 9 will not be here. Then we have 10, 11, 12 and so on. We have to remove all those elements which are perfect squares. So 4 will not be here, 9 will not be here, 16 will not be here, 25 will not be present in the set, like this. Next, seventh part says that X is a perfect cube. So we have to remove the perfect, like 1 is cube of 1, we have to remove that. 8 is cube of 3, it should not be present in the set. Then 27 should not be present. So the set were containing 2, 3, 4, 5, 6, 7, 8 should not be present, then 9, like this. We have to remove all the perfect cubes. Next is 8th part, which says that X plus 5 equal to 8. So what is the value of X? X value is 3. So this is the set which contains only one element, which is 3. So we have to write the complement of 3. So what will be the complement of 3? All the natural numbers. We have to just remove one element, which is 3. So this set will look like 1, 2, we have to remove 3, 4, 5, 6 and so on. Right. 9th part says that we have to construct this. Let us see what is this set first. This is 2x is equals to 4, then x value is 2. So this is the set which contains only one element, which is 2. So complement of 2 will be all the natural numbers except 2. Then 10th part says that x should be greater than or equal to 7. So this set will look like 7, 8, 9 and so on and on. So this complement will be which is not present in this set, which are 1, 2, 3, 4, 5 and 6. Next, last part is 11th part, which says that here is x is natural number and x value is this. So x will be 2x is greater than 9, x is greater than 4.5. So all those natural numbers which are greater than 4.5, so this set will look like 5, 6, 7 and so on. So we have to take its complement. Whatever is not present in this set, it is 1, 2, 3 and 4. Next is fourth question. This is the universal set. A is defined like this and B is this. So we have to verify both these De Morgan's law. So for first part, let us calculate the left hand side first. For left hand side, we need A union B's complement. So let us first calculate A union B. So A union B will be everything which is present in A, 2, 4, 6, 8 and B also. B has 2 which is already mentioned, then it is 3, then 5 and 7. So A union B is this. If I write it in a proper way, it will be 2, 3, 4, 5, 6, 7 and 8. So we have to take its complement. This is A union B. Taking its complement, A union B's complement, it will be 1 is not present here, 1 and 9. Next, let us do the right hand side for first part. It says A complement intersection with B complement. So let us first write the A complement. A complement set will look like 1, 3, 5, 7 and 9. All the elements which are not present in A set. Then we'll calculate B complement. The elements which are not present in B, it is 1, 4, 6, 8 and 9. Now we have to take its intersection. A complement intersection with B complement. Whatever is common in these two sets, the common things are 1 and 9. So as left hand side is equal to right hand side, so first one is proved. Now for second part, left hand side, we have to take A intersection B's complement. So let us first calculate A intersection B. Common elements in A and B. So 2 is common and only 2 is present in both the sets. Now we have to take its complement, A intersection B complement. What are the elements that are not present in A intersection B? So except 2, 1, 3, 4, 5, 6, 7, 8 and 9. Now for right hand side, we have to calculate A complement union with B complement. So what we'll do, we'll see the A complement and B complement values from this part. First part we have calculated, we just combined it using union. A complement union B complement is everything which is present in A complement, which is 1, 3, 5, 7, 9 and B 4 is present, 6, 8. So if I write it in a sequence, it will be 1, 3, 4, 5, 6, 7, 8 and 9. So you can see this set and this set are equal. Left hand side is equal to right hand side. So next fifth question, it's very interesting question as we have to draw the appropriate Venn diagrams. So for first part, we have to draw the universal set first, which is U. So suppose this is the universal set U. Then we'll draw A set, this is A, and then B set, this is B. Now we have to do A union B's complement. So firstly we have to look what is A union B. So A union B is all the elements of A as well as all the elements in B. Now taking its complement, A union B complement, which is not present in A union B, it will be this, which I'm shading in red color. So this is A union B's complement. Now let us do for second part. Again we have to draw the universal set U, A set and then B set. Now we have to take A complement which is not present in A, so it will be sets here, not present in A, like this, right? And then B complement which is not present in B set, it will be all these points and this also. So if we shade this region, we have to take its intersection, all those points, common elements here. So the common elements are this only if you look closely. So it will be this set. And by De Morgan's law also we know that this both should be equal. Now third part. This is the U set. This is A. This is B. Now firstly we have to see what is A intersection B. You know that A intersection B is this part, common of A and B. Taking its complement, so except this everything. So except the center part, everything is A intersection B complement, this red color, except this part. Now fourth part, we'll construct U first. Then we'll make A set and then we'll make B set. Now we have to do A complement. A complement will be this set which is not present in A. Now B complement, the elements which are not present in B, it will be this. Now taking its union, we have to consider both these things, and then if we'll shade, it will look like this. It will also be everything except this part. So by De Morgan's law also we know that second, third and fourth part will also be equal. Sixth question says that we have a universal set U, which is the set of all triangles. Then there is a set, which is the set of triangles with at least one angle different from 60. So A set has at least one angle which is not equal to 60. So its complement will be all the elements, all the angles equal to 60. Right, so if a triangle having all the angles equal to 60 is the set of equilateral triangles. So A complement with the set of equilateral triangles. Now let us come to the seventh question. We have to fill in the blanks. So first part is A union with A complement. So we have seen this in properties section also. If you see this through Venn diagram, so this is the U set, this is A set, right? A set will be this, right? A complement will be this. So if you combine all the elements of A also and A complement, what you will get? You will get the U universal set. Second part say that phi complement. Phi is an empty set, so its complement will be phi complement. Phi is an empty set, its complement will be U universal set, right? Universal set intersection with A set. So this is whole universal set, this is A set. So we have to consider the common elements in U and A. So it will be A. Third part is A intersection with A complement. So this is A set, right? This is U set. So A is this one, complement is this part. So what is common here? There is nothing common, so this will be phi. For fourth part, we have to take U set and this is A. It says that U complement. What is not present in U? Everything we talk is inside U only. So what is not present in U? It is phi, empty. We have to take its intersection with A. What is common in A and phi? It is nothing. There is nothing common. So this answer will also be phi. So that's all for all the exercise questions of exercise 1.5. So we'll see next exercise in the next video.